Hi, geometry. Let's talk today about what does it mean for two figures to be congruent. Okay, across the top here I put a definition. So if two figures are congruent, then all of their corresponding parts are congruent. It's easy enough to read, but what does that mean? Okay, so let's look at the first two figures. I can see that this purple figure is the exact same shape, size, everything of the green figure. It's just been translated to the right. Or I can say the green figure is the exact same shape, size as the purple figure. It's just been translated to the left. So a very non-formal way to look at the definition of congruent figures is to say, well, if two shapes are the exact same, their sizes are the same, in fact, one could sit on top of the other one exactly, then they are in fact congruent figures. Okay, so now let's look at the arrows. They are definitely the same shape. They are both arrows. But are they the same size? If I take one, it doesn't fit exactly on top of the other one. So now what? So if a straight translation isn't enough, then maybe I need to take a look at a rotation as well. If I rotate the arrow, can I get it to match exactly with the orange arrow? And the answer to that is yes. A rotation lets me sit this, it's pretty close. I'd have to rotate it slightly more, but you can see that yes, these arrows are in fact the same size. They are the same shape, so therefore they are congruent figures. Okay, and we've got one last set. I've got these two stars. They look the same. They are in fact the same shape, but are they the same size? Can I take the pink star and translate it over and sit it on top of the blue star? Well, just like we had started with the arrows originally, a simple translation is not going to be enough. When I translate them, they don't have the exact same alignment. So I would have to have a little bit of a rotation on the pink star as well. Okay, fine. We can see that with a little bit of rotation, the pink star will match up on the blue star. Got it. So now the question comes back to, again, what is this definition of congruent figures? What does it mean for all parts to be congruent? In order for two shapes to be congruent, okay, yes, we've said they need to be the same size, same shape. But the way you're going to achieve that is that one shape, or the second shape, if you will, must be a transformation or a series of transformations of the first shape. So here, it's a simple translation. Now this is maybe a reflection, maybe a translation, and this one's a little bit of a rotation and maybe a translation. So if you can say that one shape is absolutely a translation of the other, or a rotation of the other, or a reflection of the other, or some combination of that, then yes, you're going to have congruent figures because those three transformations keep all the corresponding parts congruent. Okay, so for the rest of this video, we're going to focus on not just any figures, but congruent triangles specifically. Now remember, a triangle has 6 parts. A triangle has 3 sides, and it has 3 angles. So in order for two triangles to be congruent, all 6 parts of one triangle must be congruent to all 6 parts of the other triangle. So what does that look like? Without having a picture, let's look just at the notation here. I am telling you that triangle ABC is congruent to triangle LXM. Okay, we have to be able to list out all 6 congruent statements for this pair of congruent triangles. Okay, so first, look at the 3 sets of angles. Now, how did I decide who angle A was congruent to? Okay, angle A is the first letter here, and the first letter over here is L. So that's how I decided that angle A was congruent to angle L. Okay, so next up, angle B is in the middle, and X is in the middle. So therefore, I'm able to conclude that angle B is congruent to angle X. For my last set of angles, I see that C is the third letter and M is the third letter, so that gets me angle C is congruent to angle M. Okay, so kind of nice. I have a congruent statement, not a picture, but I was still able to decipher and figure out which 3 pairs of angles were congruent. How about the sides? Okay, so we should be able to look at the sides pretty quickly because we've already done this for the angles. So look at A and B are the first 2 letters here, and L and X are the first two letters here, which tells me that side AB must be congruent to side LX because they're in the same location in the congruent statement for the triangles. So here we go, side AB congruent to side LX. Next up, we have the middle letter, third letter, and the middle letter, third letter. So we can see that side BC must be congruent to side XM. Okay, third set of sides. The first letter and the third letter, so the first letter and the third letter, we have A and we have C. The first letter and the third letter, we have an L and we have an M. So that gets me side AC congruent to side LM. So see, even without a diagram, this congruent statement here is powerful enough to give me my 6 congruent parts, or 6 pairs of congruent parts, if you will, my 3 pairs of congruent sides, my 3 pairs of congruent angles for my 2 congruent triangles. So the order here, super important. Remember that. Okay, so let's flip everything around now. We still are talking about congruent triangles. Congruent triangles have 6 congruent parts, congruent to 6 congruent parts. So last time I gave you the statement and you listed out the 6 parts that were congruent. This time, in the form of a picture, not written, but in form of a picture, I'm giving you the 6 congruent parts and I want you to come up with the congruent statement. So we have to take what we did on the last slide and do it backwards. So how do we do that? I'm going to look right here and say, okay, the first triangle was set for me. A is the first letter. A has 2 tick marks. So if I look at angle T on the second triangle, T has 2 tick marks, right? The diagram tells me that angle A and angle T are congruent angles. So that means in my congruent statement over here, A and T have to be in the same location. If A is first, T is first. Now I see that B is second. So if B is the second letter, then I have to figure out, well, who matches up with B? B is a right angle here, and that matches up with angle S also being a right angle. So if B is the second letter, then S must be the second letter because those are congruent angles. So for my third letter, I have to figure out, well, who's left? I've got angle C, and angle C has 1 tick mark, which is congruent to angle R, who also has 1 tick mark. So C is in the third spot, R is in the third spot. And now I can see that my congruent statement says triangle ABC is congruent to triangle TSR, where these 3 letters match angle for angle with these 3 letters. Or if you'd rather, side AB, okay, first letter, second letter, matches with side TS, first letter, second letter. Okay, side BC, so second letter, third letter, BC matches up, better be with SR, which it does. There's the 2 tick marks that make them congruent. My third pair of sides, side AC, that's my hypotenuse, and side TR is also my hypotenuse. So we took a diagram and we came up with a congruent statement. So here's my next question for you. If I change triangle ABC to triangle BAC, does this side change as well? Or is this side always going to just be TSR? Okay, hopefully you've been paying attention and you know, yes, this has to change because A is in the first spot, A matches up with T. So if A is in the second spot, now T has to go in the middle spot, in the second spot. Okay, B matches up with S. So if B is in the second spot, S is in the second spot. If B is in the first spot, however, now S has to go in the first spot. Okay, and then angle C matched up with angle R. So if C's in the third spot, R's in the third spot. Oh, and C stayed in the third spot, so R stays in the third spot. And there you have it. Just remember, the first triangle is irrelevant. If it's not set for you, you can put the first 3 letters in any order you want. What is super important is that you match the second set of 3 letters. So the second triangle has to coordinate and match with the first. It doesn't matter if you're given a diagram or if you're given a congruent statement. Okay? The corresponding parts have to match.
But now, look at this picture. Are these triangles congruent? I have three pairs of congruent angles. I have D congruent to C. I have the right angle here, the right angle here. I have the one with the dot there and the dot there. I have this side congruent to this side, so I've got these guys congruent. I've got these guys congruent, but what's my sixth part? So listing things out, I have my three pairs of congruent angles. We saw that. Okay, I definitely have two pairs of congruent sides, but what do I list as my third pair of congruent sides? My third pair of congruent sides has to be this side right here. This side AB is in this left triangle, but it is also in the right triangle. So what allows me to say something is congruent to itself? The reflexive property. The reflexive property says exactly this. It says any segment or angle is congruent to itself. So in a two-column proof, I can pull this right from the diagram. I can see that side AB is in both triangles. So if I need it as one of my congruent parts, I can say side AB is congruent to side AB, or segment AB is congruent to segment AB by the reflexive property.
Okay, so now if all 6 parts of this triangle are congruent to all 6 parts of this triangle, and they are, then I should be able to create a congruent statement for the congruent triangles. So again, we're going to go to the picture. I think the picture is a little bit easier. I have A in the first spot. So if A is in the first spot, let's look at what A is. A on the first triangle, ABD, that's the left triangle, has the little dot. Who has the little dot on the right triangle? Right there. That would be B. So next up, in the first triangle, we have the letter B in the second spot. So I need to figure out who goes in the second spot here. So going to the diagram, on the left triangle, B is my right angle. Who's my right angle in the second triangle? That would be A. Okay, next up, I've got letter D in the third spot. So who goes in the third spot here? Well, we're thinking it has to be C because that's the only letter left in the right triangle, but let's go ahead and confirm that. D has this single tick mark across it. And so if I go to the right triangle, it does in fact match up with C. So when I put my C in there, now I'm able to read my congruent triangles as triangle ABD congruent to triangle BAC. Remember, this triangle order, the order of these letters, that was arbitrary. It didn't matter. It was random. These matter. They have to match how you set the first triangle. Quick little side note, I think when you have triangles that share a side or even share an angle, we see side AB is in both. I think it's very common for people to make the mistake and say triangle ABD is congruent to triangle ABC. And they think because this says AB, this should say AB, and they don't even think about it. So take your time and match angle for angle in your diagram so that you don't make that mistake.